Welcome back to physics. And today, or this weekend, we're going to add on 2 more kinematic equations so that we have all 5 kinematic equations that we possibly need.
These are the big 5. Really, it should be the big 3. That's what we kind of talk about. And those 3 would be number 1, number 2, and number 3. Those are the 3 biggest equations that we use pretty much throughout the year. Some of them we use more often than others, like number 2 is probably going to be the most often equation that you're going to use. Number 3 you're going to have to use in specific situations, and we'll talk about when that occurs. And number 1 is really the same thing as A is equal to delta V over T, so that one get used a lot also. Please though, with this equation, people try to use it in the wrong situation, and as we start to use these equations more, you'll see which one is appropriate at which time, because that's really the biggest problem. Which equation do you pick? So we're going to run through some examples today, right now, so you can start getting practice on picking the right equation.
Using that guess method is really going to help you as well. Once you have all those given information and unknowns written down, the equation becomes a little bit more obvious, because you know which variables you're talking about, and you know what equation you can use. So really quick, if we just look at these, if you look at equation number 3, out of all the variables we talked about, one of them isn't in it. That variable is time. So if you know nothing about your time, that's probably going to be the equation that you go to, because you probably have all of this other information. And it's the only equation that we have up here without time in it. So you need to be strategic in that way, and writing out your givens and your unknowns is going to help you.
Also, one of my favorite sayings is, if you don't have the time, don't waste time trying to find time. Don't do it. Just use this one.
Alright, so let's look at some examples. These are old Regents questions. Okay, so our first example says, what is the final speed of an object that starts from rest and accelerates uniformly at 4 meters per second squared over a distance of 8 meters?
Before we move on, what you should do right now is pause the video, write down the question, try it yourself, and then come back and look at us solve it. If you're not trying it on your own first, you're not going to learn. So pause right now.
Welcome back. And first thing we need to do as we go through that guess method is figure out what is our given information. So as I read through this, I see that the object starts from rest. That's one of those key phrases that we've been talking about, and that's telling us that our initial velocity is 0. I'm going to keep reading and read that it accelerates uniformly at 4 meters per second squared. That means my acceleration is 4 meters per second squared. Over a distance of 8 meters. So then I have to figure out, well, what are they trying to ask me to solve for? The first part of this sentence tells me what is the final speed, so that's my unknown. Now I'm going to just write our equations over here, just our big 3, so we have them for reference. You should have them on the back of your reference table right now.
Okay, right now, what I've done is I write unknown. I've written unknown of VF, but the question says speed. Is it okay for me to write VF if the question asks for speed? Yes, it is. In this case, your velocity and your speed are the same. Why? Because we have made no reference to direction. Since we don't know the direction, your velocity and your speed would be the same thing. So when you give this answer, you're not going to give the direction because we don't know it. All you're giving is the magnitude of the velocity, which is the speed.
So we have VIAD, and we're trying to solve for VF. So I'm going to go through a slightly slower process. You'll get quicker at this as you continue to do more problems and use these equations and become more comfortable with them. But I'm going to go through and I'm going to look at my first equation. I'm solving for VF, so that's okay. I have VI, I have A, but I also know nothing about my time, so I can't use that equation.
Again, don't waste time trying to find time.
I have my distance, I have my VI, I don't have time, and that's not what I'm solving for. Goodbye. So it has to be this equation. I'm trying to solve for my VF, I have my VI, I have my A, I have my D. 2 is just a number. So I can use this equation of VF squared equals VI squared plus 2AD.
Equals.
Now, a lot of times in questions, especially when we talk about starting from rest or coming to a stop, we have things that equal 0. So we can kind of simplify down our equation a little bit because that VI squared, 0 squared is just 0. So we're really only looking at, for this example, VF squared equals 2AD. So then we're going to substitute in. Can you do that?
Sure. So we'll substitute in. Remember, when you substitute, and this is a big problem, this is where you're going to lose points, you substitute with the units. So my VF squared is equal to 2 times A times D, which is 2 times 4 meters per second squared times 8 meters. Well, 2 times 4 is 8, and 8 times 8 is 64.
But we have to be careful, because if we follow through this equation, we're seeing VF squared is 64. So I'm not done yet.
I'd also like to point out that her units are technically not right. Now, what happens? You take meters over second squared and multiply by meters. Meters times meters is meters squared. So your unit now becomes 64 meters squared over seconds squared. You should realize that you're not done. You should realize 2 ways. First, it says VF squared. So you solve for VF squared. You did not solve for VF. You should also recognize that you're not done because the unit for velocity is not meters squared over seconds squared. It is meters over second. So what do? You take the square root.
We should know that the square root of 64 is 8.
Now, you take the square root of meters squared, you get meters. You take the square root of seconds squared, you get seconds. So, meters over seconds. That's the proper unit for velocity. I notice in Edpuzzles, a lot of people are having problems with units. I ask you what is acceleration, and you give me meters per second. I ask you what is velocity, and you give me meters per second squared. Please know the difference. Velocity is measured in meters per second because it's distance over time, where acceleration is meters per second squared because it's velocity over time.
So we need to be very careful with that, and we can follow through the algebra to get to our final answer. Okay? You can treat all of our units just like you would variables in algebra. You know how to do x times y. You know how to do the square root of x squared. Just do the same thing. We're just doing it in units.
Your answer should go in a box. That way we know you're done. So when we're grading a test, when we're grading a quiz, we go and look for the box. You have the right answer. Good. You don't have the right answer, then we'll go back and figure out where your mistake is. Notice also we are checking to make sure units are here in your substitution. You lose a point for that.
Remember that you also lose a point if you don't write down that equation. So a lot of things that we have to think about, follow through the process now, and you'll be good. All right, let's do one more question. So we have a truck initially traveling at a speed of 22 meters per second, increases speed at a constant rate of 2.4 meters per second squared for 3.2 seconds. What is the total distance traveled by the truck during this 3.2 second time interval? You should be doing the same thing you did before. Time out, pause us, write it down, see how far you can get. Try and solve through this entire thing.
Applause.
And welcome back. So, Mr. Petersak started writing out our givens already. We have that initial speed of 22 meters per second. We have it increasing at a constant rate of 2.4 meters per second squared. Now, it doesn't explicitly say it's at an acceleration of 2.4 meters per second squared. But those units in here should be a key to you. It's meters per second squared. Well, that has to be my acceleration. So it says it's at a constant rate, but the units can also help you figure out that that's your acceleration.
Okay, this one says what is the total distance? So my unknown is distance. Now, in this particular case, the distance and the displacement would be the same. Don't get hung up on the words. The question is just going to ask you for distance. So you just give me a number. If the question asked you for displacement and gave you a direction, you would then have to give that distance, that number distance, the magnitude, plus a direction. But for this particular question, it just says what is the distance. So in that case, I don't care about direction. Just give me a number with a unit. So I've already written down my givens. VI is equal to 22 meters per second. A is equal to, or acceleration is equal to 2.4 meters per second squared, and time is 3.2 seconds. My unknown is distance. Take a look at your equations. Which one should we use?
Hopefully you were able to pick out that we should be using this second equation based on what we have. We're trying to solve for distance, we have initial velocity, we have time, we have acceleration, and we have time again.
I want to stop for 1 second to make sure you realize we do not have to use these equations to solve for the thing that it says it's equal to. Just because it says d is equal to VIT plus 1 half AT squared does not mean you cannot use that equation to solve for anything else in that equation. You're not always going to be using the equation the way it looks. You may have to rearrange things. For example, what if I asked you to do this equation, but asked you to solve for distance? You need to be able to do that.
So we'll get into some of those examples a little bit more next week, but for right now, let's kind of finish solving through this. So we have our equation of d equals VIT plus 1 half AT squared. Make sure you write it out, keeping in mind that I is a subscript underneath it. And then we're going to plug in. So we're looking for distance. We have a VI, 22 meters per second.
Now this is a long equation to write out, but you must write out every single piece with every single unit. So it would read 22 meters per second times 3.2 seconds plus 1 half 2.4 meters per second squared times 3.2 seconds squared. Your order of operations is very important in this equation. You must do this multiplication. You must do this square and then this multiplication.
Noticing that that squared is only attached to your t. The only thing that gets squared in there is your time. So be careful on that.
Now also notice this. This will become very important, especially if your acceleration was negative. If you were slowing down, or if this car was slowing down, this plus sign is no longer a plus sign. Because what happens is you would have a negative here, and that negative would carry through, and that plus sign becomes a negative sign. So please, be very careful with your signs.
So I'm going to plug this into my calculator in pieces to make sure that I make no mistakes when it comes to solving this out. So first I'm going to plug in this red circle here and do 22 times 3.2 seconds, which gives me 70.4 meters. And then I'm going to plug in my 1 half AT squared piece of it, and that's giving me 12.288 meters.
Now, hold on one more second. Where did this meters come from? Let's make sure you see it. Because seconds squared would be seconds squared, right? You multiply that by meters over seconds squared. What happens to seconds squared? It goes away. So the only thing you would have left would be m.
So then when I add those, I end up with 82.688 meters. And we can leave that to 3 decimal places if you want to round it down to 2 and do 82.69 meters. That's okay too.
What I would do is just round it to a whole number and say 83.
So it depends on the question. It depends if this is multiple choice or not, what they're going to give you as possible answers. So they might give you 83, and this does round to 83 meters. So that's okay.
All right, that was a lot of stuff and a lot of important stuff, but it is a basis for everything that we do going on. I keep saying this, and I sound like a broken record, that everything we're doing right now serves as a foundation for what we're going to do in the future. So again, if you have problems with this, you must fix it. Either by yourself, by watching this video over and over and over and over until you understand it, or with us in class, or with us in extra help.
We're both here every morning, so come on in, ask us questions, so that we can solve the problems now before it gets too late.
And even if you're in my class and don't like me, go see her. If you're in her class and don't like her, come see me. You have options. Please don't make mistakes. Anything else?
No, that's it.
Great. Have a great night.